Vanilla OS. This is probably one of the more requested Linux distributions that I go ahead and take a look at, and one of the main reasons for this is how truly unique the operating system actually is. It is based on Ubuntu, but it is not your typical Ubuntu spinoff where maybe they change the desktop environment and do a customization here and there. This distribution can be compared to something like Fedora Silverblue, which we have checked out previously on this channel, and that's because the actual file system structure of the thing is immutable and there are other tools and whatnot to help you manage that, and you could actually use packages from different operating systems other than Ubuntu, such as Fedora and Arch Linux. But before we get too far, let's back up a little bit and talk about the immutability factor. This is gaining popularity as such distributions are standardized, so they are basically identical on every single setup. This enhances security because it makes it difficult for some bad acting program to go ahead and actually affect the core components of your system, such as the kernel, as it cannot be altered. Extra packages are installed in a separate section from the main system, often in its own containerized instances. When updating, Vanilla OS handles this using a tool called Abroot. Abroot keeps two separate states of your system. You have your present and your future, and when something new is packaged, for example a kernel, it is added to the future state, and then that will not change until your system reboots, making the future state the present. Now when it comes to installing packages using a package system like DNF, APT, Pacman, this often installs binaries and other required files in root system directories. This is a disadvantage because then it becomes difficult to tell which components are part of the stock system and which were added by third-party programs, thus complicating troubleshooting and even causing some security concerns. Now we've already been presented with some solutions such as Snap, Flatpaks, and app images. Flatpak being my preference is the default package distribution system within Vanilla OS, and the packages can be found through the GNOME Software Center. Now this could pose an issue as not everything is available as a Flatpak, and there will be some things you want to install through your typical repository package manager, and this is where APX comes in. Like APT, you use the command line to install various packages native to your base distribution, in this case being Ubuntu, but the key difference with APX is it will create individual containers for your packages and install all the dependencies within that container, restricting access to your system resources while still being able to use the same drivers, display server, etc. Now a really cool thing, we kind of mentioned this earlier about APX, is you are able to add flags such as --AUR, or --DNF, which will create containers based on those systems, allowing you to run Arch and Fedora packages if needed within your Ubuntu-based system and tightly integrating them within your host system. And if really needed for something like a kernel module, driver, you can install packages on the host using that AB tool or Abroot tool that we mentioned earlier, but this is not recommended. Vanilla OS also has other system-specific tools such as VSO for maintenance tasks, and a whole bunch more. I'm not going to be able to cover every single little specific thing in this video, but of course I'll link down below to the documentation. Now, before we actually dive on into Vanilla OS, check out the system and some of the GUI components and how to actually use some of these features, I must first thank the sponsor of today's video, Linode. I've been using Linode for years for just about anything that I need hosted over on the interwebs, whether that be my old forums, website, Nextcloud instance, and a whole lot more. You can pick between a wide variety of Linux distributions or use their marketplace one-click installers to get a service spun up with ease. You can easily SSH in, access your server via terminal, and do really whatever you need to do. And better yet, there is a $100 60-day credit if you are interested in trying it out today. Go ahead and use the link down below. So what I'm going to do real quick, I'm going to fire up a virtual machine in GNOME boxes with Vanilla OS to go ahead and check it out. Alright, so here we are. The system is installed. This is actually the second take of this. I did run into some issues, which I will be talking about. When you first boot up the system, you are prompted with this right here. This is your kind of get started little helper walkthrough thing where you can pick your color scheme. Honestly, the dark looks really good. For the video, we're going to stick with light. And then here you have package manager options, Flatpak, app image, you could go next. Here, this is really cool. You can select what components you want to install. So we have our core applications, and you could go through and select specifically what of those core applications you're actually going to use. You have other options such as LibreOffice, and then down here under common utilities, you're going to have a lot of different things that you might want to add, including bottles, which I'm fairly certain is from the exact same developer of Vanilla OS, and then some other gaming tools, some virtualization software, which boxes right here is what I'm currently using to demo this. And if we go next, you have time shift, skip that, open VM tools, you could click install restricted codecs, and that's going to go through a process and install all of that. Now, where we get into one of the really unique things about this operating system is if we go over here to the Vanilla OS Control Center. Here you can see loading drivers, none available. If you had something like a AMD GPU, it's assumed the drivers would show up there. You'd be able to install them. Under updates, this isn't actually updating, rather out the update settings, such as auto update, specific schedules, things like that. But where it gets really interesting, and like we mentioned in the intro, is the subsystem right here. This is where we can go ahead and add the Arch Linux subsystem, OpenSUSE subsystem, and a whole lot more. You can see I was playing around with it. I actually have a couple different things installed. And if I, for example, open up my Fedora subsystem, this is what it's going to look like. Now we're getting an error here because the command is currently like in the wrong order from what it should be to work properly. So it's just a little issue that's probably going to be fixed in an update. So actually trying to launch things through here at the moment, such as the Arch Linux subsystem here, if I try to add that, it's going to be the same situation where I get a error unknown flag, but we can still install packages using this kind of containerized system. And you can see here some of the ones I was playing around with. I installed MPV within the normal Ubuntu subsystem, as well as GIMP, and then under the Fedora subsystem, I have a second copy of GIMP. And if we go under activities and we look at our applications here, we can see the two different versions of GIMP. We have GIMP on APX managed DNF. So this is a Fedora version. And then this right here is on just APX managed. So this is going to be our Ubuntu version. You can see if I open up this Fedora version right here, or the version in the Fedora repositories, it's going to open up. It's going to be pretty quick. And overall, it is a pretty good experience. So I'm going to close that out here and kind of show you an example. So if I go and I open up my console, let's move that over here, we can see some of the commands that I have been inputting. So what we need to do is APX install, and then we add the flag for whatever we want to do. So in this case, it's DNF is what I used, and GIMP. Now, for example, let's say I wanted to install Chromium from the Fedora repositories. I would just type in Chromium here, Chromium, enter, and then here you can see that it is able to find the package, and it's going to install every single dependency for this specific application into this little container that it's building. And then another example that I wanted to show you is something I did earlier, and that is a MPV. So if I look that up, it's going to give me a total download size of 57 megabytes. Now this is kind of bringing up a con to doing it containerized like this, because for example, if I go ahead and open up our software center and go search, type in MPV, we can see it right here, and we can see the actual size is 31 megabytes. So installing containerized packages like this with all of these separate dependencies may take up a little bit more room on your computer than just using the Flatpak, or with a normal system, you just install the applications and then dependencies would be shared in between applications rather than having everything in a single container. Now, one thing I haven't tested out is if the AUR flag is working. So let's go ahead, do AUR, and something in the AUR that I can grab is MailSpring, for example. Hit enter, it's going to go ahead and create that container because this is the very first time I've ran the AUR flag. So we're going to see if there's going to be any issues with this. So there we go. Now it's setting up locales. That's another issue I kind of had in my first take, is my time wasn't set up right. So it just didn't work at all. There we go, downloading and installing it, yay. And boom, so it's listed out all these various dependencies. Do we want to remove the make dependencies after install? I'm just gonna say no for now and proceed with install. So total size is gonna be 175 megabytes. So let's go ahead and proceed with that installation. And having access to the AUR and basically this kind of version of Ubuntu is awesome. One of the big reasons a lot of people use Arch Linux is for the AUR, because there's just one or two packages that you might need specifically from it. This basically gives us that. That is if it works. All right, there we go. MailSpring will appear in your applications in a few seconds, so let's go ahead and see if it's in there. And there it is. We can see MailSpring on APX_manage to AUR. give that an open, and then the application is going to open in its very own containerized instance. That is maybe. Second time's a charm? Okay, so it's not wanting to open up MailSpring. Let's give one more shot with another application. So let's go ahead and try something else here. Let's try to grab a Tor browser through the AUR, see if that works. And it says, okay, the Tor browser will appear in a few seconds. Let's see if it has. Which it has. Now let's see if it will open, because MailSpring for some reason is not wanting to open. Oh, there it is. Cool. All right, so here is Tor running in the container through or installed through the AUR. Pretty cool thing. And there we go. Now we're now connected to Tor. So super cool. Fascinating stuff. So it's probably just this specific instance of MailSpring, not to do with the system itself. Oh, well, there we go. So I guess it just needed a couple attempts to think about it. Nice. Super fascinating. Cool stuff, cool stuff. So let's close out of there. And of course, really beyond that, it's your typical kind of stock GNOME environment. We have the stock GNOME web browser, photos, files, and everything is going to be pretty vanilla. Other than there's a couple things that aren't really too vanilla. If we go over here, we do have Extension Manager installed, which is nice. This is the one that allows you to browse and install directly through here, so you don't have to get like a Firefox extension and all that. There are some system extensions, but all of them are disabled. A lot of these you'd probably want to go ahead and enable anyways, but that is a super nice thing to have. And then of course on the system, other than the things that we've just added, it's basically everything we selected during that initial installation prompt. There's not much more past here. One thing that is worth mentioning, and a criticism, is how much disk space this thing takes up. If we go over to my 129 gig hard disk here, you can see there is really a lot going on. There are two 20 gigabyte root partitions. We have A and B. So just in our actual root file system, it's taking 40 gigabytes of space. There is work being done in development to make this under 10 gigabytes per root partition. But that is something to keep note of, especially if you're somebody with like a 128 gigabyte hard drive, or even if you have a 256 gig hard drive. To have 40 gigs just taken like that right away is a lot, especially if you want to install things through this containerized system, as these generally do take up more storage because, like we said, all the dependencies need to be installed in each specific container. So when possible, it's usually a better idea just to use Flatpak instead of using this, unless if you need something from the AUR or whatever, which just being able to do that in Ubuntu is cool enough. Now, this is a really cool system, and I'm thinking about not switching to it, but I'm thinking about using it on one of my machines for a longer term so I could provide better feedback and make a longer dedicated review. For now, I do recommend you go check out the video from Switched to Linux. He has a video on this. It's a little longer, goes into more detail, mention some of the things that I said, but overall it's a really good video if you do want to learn more about this system. And with all that, a big thank you first of all to the Vanilla OS Discord, specifically Monster, who is a contributor and a moderator on that Discord, helped me out with a couple of the issues that I had. Big thank you. And with all that, I do hope you all have an absolutely beautiful day, and goodbye.